Okay, so here we are, got year 10 in here, and we are having a look at memory terminology. The main thing about computer memory is it's split into primary and secondary storage. So primary storage is for when the computer is running. It's where it stores all of the programs that it's currently running, the data it's currently working on, all of that kind of thing. Secondary storage is where data gets stored permanently. So when a program is running, it gets loaded from the secondary storage, the hard disk or something, into the primary storage, and then it gets run there. When you save a file, it saves back to the secondary storage. So we all know, for example, when we're using Microsoft Word, that when we save a file, it saves to the hard disk. If it's, however, we shut down Word without saving it, it disappears. Very, very straightforward. So you've got the working memory of the computer here, and then you've got the secondary storage, which is permanent. The proper words for this is volatile and non-volatile. Within primary storage, you've got a memory hierarchy, and I'm going to talk about this in just a second. But the three things in that are registers, cache, and RAM. So we've got registers which reside inside the CPU. There are a small number of these inside the CPU, and they're used for holding the results of calculations, loading things in that the program is currently working on. So for example, when you do an assignment in a program, it will load the value on the right hand side into the registers first. It will work out all the sums, and then it will store it back to the RAM. So the registers really are, there's a tiny number of them, tiny number. They are as fast as the processor, so they are lightning fast. So they're running at 3.4 gigahertz or whatever the processor is. Now, then you have this memory hierarchy, because RAM is quite slow in comparison. You've got some speeds and sizes down the bottom here that show you. So the level 1 cache is inside the processor itself, and it holds about 128 kilobytes, so that's binary kilobytes, inside the CPU itself. And as you can see, you can transfer 700 gigabytes a second. So that is practically the whole of your hard disk transferred inside 3 seconds. It is absolutely blisteringly fast. Because it's blisteringly fast, it's also very expensive. So we don't want to have to buy loads and loads and loads of it. Then we have the level 2 cache, which is a bit bigger and a bit slower. And then we have the main memory, which is huge, but much slower again. So what happens is when the register wants to write a value to the RAM, it writes it to the level 1 cache. This then writes it to the level 2 cache, and this then writes it to the main memory. All the CPU has to do is write it to the level 1 cache and then get on with its business. It doesn't need to worry about doing anything else. And then the data will trickle up the chain to the main memory at the top here. When it reads a value, it asks the level 1 cache for the value. If the value is in there, it just gives it straight back into the processor. If not, it asks the level 2 cache, and then that will go back. It gets stored in the level 1 cache straight into the processor. And if it has to go all the way to main memory and then all the way back again, it will, but that value will now be stored in the cache. So if you consider something like a for loop where you have a variable for I is equal to 1 to 1 million, you have a variable that's changing all the time. Instead of waiting each time to go to the main memory and back, what you have is it's in the level 1 cache and it's just getting updated practically at the speed of the processor here, and then this is getting stored back up the chain, so you end up with an identical copy of that in main memory. So that is what primary memory is for, and all the reads and writes go through each level. Some processors have 4 or even 5 levels of cache, and it's one of the strategies that's really enabled us to get much, much faster computers. Okay, so on to the next thing. This is very simple and straightforward. This is your secondary storage where you store stuff, and there are more examples than these, but these are the most important ones. So, magnetic storage, the storage is stored as ones and zeros with little magnets. The magnet's up one way, it's a 1. Magnet's up the other way, it's a 0. You've got some price data. We do need to know about this. The other key thing about magnetic storage is it involves moving parts, which makes it less reliable. We've got solid state storage, so USB sticks or solid state drives. They are more reliable because they don't have moving parts, but they do fail after a shorter amount of time. And they're also much, much more expensive, but also much faster. There's a theme here: you pay for what you get. Or you get what you pay for, should I say. If a technology doesn't have that, then of course it just falls out of use. Optical drives, we've got CDs, DVDs, Blu-rays. A couple of years ago, everybody would have known exactly what all of these are, but of course everything's coming over the internet now, so this means that it's less and less used. It's got some capacities here. We should know these capacities, and we should also know these transfer speeds for each technology. And that's what we need to know in terms of storage. Next time we'll go into virtual memory and memory management. Any questions? Better. What's tape? So a tape is a magnetic tape, like an old VHS cassette. You seen those? So what happens is you put it in the machine and it turns around the wheels on the spools and it drags the tape past a reader head. So the reader head is at the top and the tape comes past the reader head, and it can then read or write ones or zeros magnetically onto that tape. Any other questions? Ahmet.
What would you consider the most efficient secondary storage?
So in terms of secondary storage, the fastest you can get is solid state drives. In terms of reliability, solid state drives fail after a given amount of time. You can only write to every bit on a solid state drive. I think it's about sort of 10,000 times you can change the value before it starts to fail. There's some clever software which shifts things around, which means that doesn't affect you for longer, but hard disks tend to last for much longer. But solid state drives are much, much, much quicker. Any more questions? Good. Well, by next lesson, next week, well, not next week, it's half term, week after, we will know all this.